Hello all, welcome back to Sri Sai Tech Edu YouTube channel Read Lead Success. I am dealing with the subject network analysis and control systems. We have already done with the module 1 videos. I have already uploaded it. In module 2 also the first topic is done, that is one port network. Now we will see the next topic in two port networks. Already we have done with the one port network. So we will start in this video. We will learn admittance parameters, its theory and problematic questions. We will consider two port as shown in the figure. You can see it is a two port network with I1 V1 and I2 V2. The voltage and current at the input terminals as V1 and I1 and V2 as I2 are specified at the output port. We will consider a two port network. We find admittance parameters in this two port network. Admittance parameters means, if you remember, admittance is nothing but inverse of Z, and unit of admittance is Simon, that is SIMEN, Simon, or simply we will mention at S. So now we will see how to find the admittance parameters. First we will learn the equations of the admittance parameters and see some problems. If you see here, I1 and I2 are both customarily selected as in the network at the upper conductors and at the lower conductors. Current here it is seen as it is into the network, and here we consider it as output outside the network. Upper conductors we consider it as inwards and down conductors as outwards. We consider in that way. Then I1 may be considered to be superposition of two components, one caused by V1 and V2. This I1 may be, it is of superposition of two components, that is depends upon the cause of V1 and V2 on I1. Then same in the same way I2, for I2 also it is a superposition of V1 and V2. So we can say that the same argument is applied to I2, the same argument. So we may begin with the set of equations. What are the set of equations we have? These equations are very important for the I parameters to find. Why? Because y11, y11, y12, y21 and y2 are the nothing but what? Y parameters we are going to find. You know that V is equals to IR, and R is nothing but, you know, that is equivalent to impedance. So 1 by Y we can write. If you see, I is equals to Vy. If you see here, you can see I is equals to Vy component, I is equals to Vy component, It is in that form only. So you need to remember in this way. I1 is equals to Y11 V1, Y12 V2. Then I2 is equals to Y21 V1 plus Y22 V2. Then unit of Y or admittance is what? Ampere per volt. By ampere per volt, Y is equals to I by V. So I is nothing but ampere and V is nothing but volt. Ampere by volt, or it can simply be written as what? This is as Simon, or it can be also told as mho. Inverse for resistance we say ohm, right? For admittance we write as mho, that is in this way. This you can write. You can remember that mho also we will say as unit of admittance. Like this, mho. Siemens, it has three units, ampere per volt or Siemens or mho. It is the unit of admittance. Here we defined a 2 cross 1 column matrix, that is I1 and I2. Why? Because it has two currents, that is I1 and I2. I is equals to I1 and I2. Why? We have already seen from this from the equation, that is y11, y12, y21, y22 in the form of matrix. Then 2:1 column matrix of v1 and y2. Why? Because it has v1 and v2. So v1 and v2. We have already know that I is nothing but I is equals to, I is equals to y into v. So I1, I2, v1, v2, y1, y12, y21, y22. If you see, it is in the form of matrix. After finding this, you can write that, and the matrix multiplication of right hand side gives us the equality. If you see, y11 v1 plus y12 v2, it is multiplication, matrix multiplication, y21 v1 plus y22 v2. You will get as this in this way. After this, Consider I1 and I2 is equals to y11, what we got previously, that equation, that matrix form. From this you can see each of y parameters may be described as current voltage ratio with either V1 equals to 0, that input terminal short circuited, V2 equals to 0, the output terminal short circuited. Either V1 equals to short circuited or V2 is equals to short circuited. Initially if you see here y11 equals to what? I1 by V1, I1 by V1. And then what happens is V2 will be short circuited. When you consider y12, when you consider this y12, I1 by V2 we will get, this will be short circuited. So V1 equals to 0. Then if you consider y21 is equals to I2 by V1, then V2 will be short circuited. This will be 0. V2 will be 0. V2 will be short circuited. Then if y22 you want, then y22 is equals to I2 by V2, then V1 will be short circuited, that is 0. Y1 is equals to 0. You need to remember these equations. See, you need to write in this way. y11 is equals to I1 by V1, V2 is equals to 0, y12 is equals to I1 by V2, V1 equals to 0, y21 is equals to I2 by V1, V2 is equals to 0, y22 is equals to I2 by V2, V1 is equals to 0. If you remember the equations what I told in this form, I is equals to YV, then you can easily remember this. You can write easily this. When you are considering y11, it is y11 is a component for V1, so V2 will be 0. Then y21 is a component of V1, so V2 will be 0. In the same way for V2, if y12 is a component of V2, so V1 will be 0. y22 is a component of V2, so V1 will be 0. Like that you can remember from the equations. These equations, if you remember the initial equations, it is easy to remember these values. Because each parameter is an admittance which is obtained by short circuiting either the output or input port, the y parameters are also known as what? Short circuit admittance parameters. Why? Because if you see here, to find y11, y12, y21, y22, what we are doing? We are either short circuiting output parameters, output port or input port. So it is also known as short circuit admittance parameters. Specifically, specific name for y11 is what? Short circuit input admittance. It is. Then y22 is short circuit output admittance, and y12 and y21 are what? Short circuit transfer admittance. These two are transfer admittances, and these two, y11 is input admittance, y22 is output admittance. This is the theory. Now we will go to the problems. Find the 4 short circuit admittance parameters for the resistive 2-port shown in figure. If you see here, there is 2-port V1, I1, V2, I2. What we need to do? We need to find y11, y12, y21, y22. They are asking admittance parameters. How to find? We will see that now. If you see here, if you consider here this as node 1 and this as node 2, V1 and V2, we can easily find. How to do? First you write the equations of y parameters. What it is? I1 is equal to y11 V1 plus y12 V2. I2 is equal to y21 V1 plus y22 V2. If you write this, it will be easy. After writing, apply KCL to node 1. When you apply KCL to node 1, if you see I1 is coming into the node, so I1, sum of incoming currents, I1 is equals to outgoing currents. This is considered as one outgoing current, that is V1 by 5. Then this is considered as another outgoing current, so it is with respect to first node, so V1 minus V2 by 10. Why? Because I is equals to V by R. If you don't know how to find KCL and KVL, you can see my previous videos. There is a separate video for mesh analysis and nodal analysis. For this, it is nodal analysis. You can see my video which is there in my YouTube channel of module 1. You can check that. After finding, if you rearrange the equations and if you calculate I1 is equal to 0.3 V1 minus 0.1 V2, you will get comparing this equation with 1. If you see similarities, see I1 place I1 is there. Y11 V1, Y11 V1. This is Y11. Then y12 V2 minus 0.1 is y12. So V2. If you compare them, you will get y11 as what? 0.3 Siemens. Why? Because it is admittance, you will write as Siemens. Y12 is minus 0.1 Siemens. Then apply KCL to node 2. In the same way, you apply KCL to node 2. As I2 is the incoming current, I2 will be equals to V2 by 20 is the outgoing current and V2 minus V1. Why? Because it is with respect to second node, V2 minus V1 by 10. Then if you rearrange, you will get I2 is equals to minus 0.1 V1 plus 0.15 V2. After writing this, if you compare this fourth equation with second equation, it is similar. If you see I2, Y21 V1, Y22 V2. If you compare that, you will get Y21 and Y22. So Y21 is what? Minus 0.1, Y22 is 0.15 Simon. So I1, I2, you can write in the matrix form 0.3 minus 0.1 minus 0.1, 0.15 V1, V2. From this, the Y matrix, this is the Y matrix, is this. This is what we want in the question, Y parameters. Determine the short circuit admittance parameters which completely describe the two-port network. Here two-port network is given. We need to find the short circuit admittance parameters. And if V1 is equals to 3 and V2 is equals to minus 2, find the I1 and I2. Compute I1 and I2. What they are telling, after finding the parameters, we need to put the values of V1 and V2, then find I1 and I2 values. We will see. If you see here, 8 and 10 is in parallel. You know already how to find if this resistance are in parallel. Nothing but what? Here 8 into 10 by 8 into 10 by 8 plus 10. If you do this, you will get 4.45 ohms. And you need to write the equations of Y parameters. I1 is equals to Y11 V1 plus Y12 V2. I2 is equals to Y21 V1 plus Y22 V2. Apply KCL to first node. If you see, the I1 is incoming current. The summation of incoming currents is equal to outgoing currents. Outgoing current is V1 by 11 and another outgoing current is V1 minus V2 by 4.45 at the KCL at node 1. If you rearrange the equations, you will get the equation as I1 is equal to 0.316 V1 minus 0.225 V2. Then comparing this equation 1 with the 3, if you see this I1 and I1 is same, V1, V1, V2, V2, and these are nothing but Y11 and Y12. Y11 is what? 0.316 Simon and Y12 is what? Minus 0.225 Simon. Then apply KCL to node 2 in the same way. If you see here, I2 is incoming current, outgoing current is V2 by 20 and another outgoing current is V2 minus V1 by 4.45. Then if you calculate the values, then you get I2 is equals to minus 0.225 V1 plus 0.275 V2. If you compare this fourth equation with that second equation, it is similar if you compare. Then from this you can write Y21 is equals to minus 0.225 Simon and Y22 is equals to 0.275 Simon. You can write the matrix as Y is equals to 0.316 and minus 0.225 minus 0.225 0.275 Simon. This unit is compulsory. I think in the previous question I didn't write that units. Please do write it. Simon units is compulsory. Then what is the second question of this sub question? We need to put the values. You know the equation that I1 I2 is equals to Y into V1 that is V1 and V2. V1 and V2 they have given us 3 and minus 2. If you substitute and do the matrix multiplication, that is how we will do matrix multiplication. 0.36 into minus 2 plus 0.36 into 3 plus minus 0.225 into minus 2. You will get as what? 1.398 ampere. Then for I2, minus 0.225 into 3 plus 0.275 into minus 2. If you do, you will get I2 has minus 1.225 ampere. Obtain a complete set of Y parameters to describe the two-port network. The network is given in this way. What we need to do if the network is in this way, we will see. If you see here, we will consider this as V1 and V2 and middle one as Vx. Why? Because in input and output ports anyway V1 is there, so we will consider that itself, and here we will consider between as Vx. After considering like this, for Vx node whatever we get, that value we will substitute in the before equation, so that you will get in the terms of V1 and V2 only. We will see, you will understand if you do the sum. Apply KCL at node 1. If you apply KCL at node 1, what is that? I1 is the incoming current. and then I1 and no other incoming currents, so that is equals to V1 minus V2 by 20 and V1 minus Vx by 10. If you calculate the equations, then what you will get, I1 is equals to 0.15 V1 minus 0.05 V2 and minus 0.1 Vx. Let it be, let the Vx terms come, we'll have substitute later. Then apply KCL to node 2. If you see here, I2 is the incoming current, there is no other incoming current. The next outgoing current is nothing but V2 minus V1 by 20k and V2 minus Vx by 5. You will write. Then after that, if you rearrange and calculate the values, you will get I2 is equals to minus 0.05 V1 plus 0.25 V2 minus 0.2 Vx. Now we will write the KCL for node X. If you write KCL, if you apply KCL for node X, what you will get? Here if you see, these two are incoming currents are coming here and this is outgoing current. But here, if you consider all the currents are as the outgoing currents from the node, that is also correct. Anyway, you can consider if these all are outgoing currents, then what will be? No incoming currents. So 0 is equals to Vx minus V1 by 10 and Vx minus V2 by 5 and Vx by 40, that is equals to 0. Then, so if you calculate this, you will get Vx as 0.308 V1 plus 0.615 V2. If you substitute this Vx in this and this, then that Vx term will be vanished. So we will see that. Substitute Vx of equation 3 and 1 and 2. I1 will be what? If you substitute and calculate, you will get 0.1192 V1 minus 0.1115 V2. In the same way, I2 you will get as, in the term of Vx, if you substitute the values and calculate, you will get I2 as minus 0.1115 V1 plus 0.127 V2. And from this you can write that general Y parameters. You know that I1 is equals to Y11 V1 plus Y12 V2. I2 is equals to Y21 V1 plus Y22 V2. If you compare these two equations with this equation and this equation, they are similar. From that you can write the Y parameters. So Y11 is equals to 0.1192, Y12 is equals to minus 0.1115 Simon, and Y21 is minus 0.1115 Simon, Y22 is equals to 0.127 Simon. So matrix is this. That's it. That is the question we wanted. The answer we got it. Determine the Y parameters of the two-port of figure. Define the bottom node of the figure as the reference node. That is nothing but this as reference. Reference node is nothing but you will take it as a ground. Nothing but in nodal analysis you need to consider that. And if they tell or not tell, you should consider the bottom node or any one node as the reference node and apply nodal analysis to obtain expressions for I1 and I2 in terms of V1 and V2. Use these expressions to write down the admittance parameters. Nothing but they are asking for admittance parameters. We will see. If you see here, these two are in parallel. But if you see, it is the values are given in the terms of Simon. So Y parameters only, Y values only they are given, not resistance, ohms they are not given. So there will be little change in doing this. We will see that. If you consider this as V1 and this as V2 and this as the reference node. If I am not considering this as reference node in other questions, please do consider. It is not compulsory, but it will be correct if you consider as a reference node. I think nothing but 0 volts. After considering this, what you have? KCL at node 1. If you apply KCL at node 1, I1 will be the incoming current, V1 by 0.5. We will write for if it is in the form of resistance, that is nothing but 0.1 ohms, then we would have written that V1 by 0.5. But here it have given as Simon, so we can't write V1 by 0.5. We should write V1 into 0.1. So it is not 0.5, V1 into 0.1. Why? Because V equals to IR. Yes, no. So I by Z we can write V is equals to. Now values of Y is given. Okay, Y into V equals to I. So Y is given. So YV terms you should need to write. But initially if resistance is given, what we need to do? V by R equals to I. We used to write as V by 0.1. If it is 0.1 ohms, for example, if it is given, then I1 is equals to V1 by 0.1 we need to write. But if it is given as 0.1 Simon, it is inverse of resistance. So we will write 0.1 into V1 Understood? Keep this in mind. Carefully we need to write this. After writing this, what we need to do? After that next what you have, the outgoing current is 0.2 Simon into V1 minus V2. If you rearrange the equations, you will get as what? I1 is equals to 0.3 Simon V1 minus 0.2 Simon V2. Then KCL at node 2 will be, I2 will be the incoming current and outgoing current is V2 into 0.25 Simon plus V2 minus V1 into 0.25 Simon. Okay. Then after calculating, what you will get? I2 is equals to minus 0.2 Simon into V1, then plus 0.45 Simon V2. Then if you compare with this the y parameters equation, you will get what? Y11 as 0.3, Y21 as minus 0.2, Y12 as minus 0.2, Y22 as 0.45. I hope you understood. Then Y matrix is what? You will get as this. Nothing but we write these all equations in the form of matrix, all Simon. We will go to next question. Obtain the Y parameters for the network shown in figure. If you see, by seeing this question, you feel it is very complex. It is complex only, but we can find easily. How? Because see, if you consider this as V1, this node connected here also it is same, here also same. I had already told in many problems. And consider this as VA and V2 as this node. Then apply KCL at all the nodes. As put the VA values so that it will the VA eliminates and we get the I1 and I2 in terms of Y and V. We will see now. If you consider this as V1, I didn't write here, V1, and this as V2, V2 and VA, the nodes we need to write the apply KCL at all the points. Applying KCL to node 1, 2 and A, what we get? I1 is equals to, I1 is incoming current, outgoing current is 0.6 plus V1 by 5K plus V1 minus VA by 20K. Then for I2 what we will get? For I2 incoming current is I2 and outgoing current is V2 minus VA by 10K. Only one is there. Then for the VA node, what we can do? For VA node, there are no incoming currents. Consider there is no incoming currents. Consider all are outgoing currents. If you consider outgoing currents as we are taking in opposite direction, take minus 0.1 when VA minus V2 by 10K and VA minus V1 by 20K. If you write the equations in this form, you will get the equations, 3 equations. But we want I1 and I2 in terms of Y and V. By what we have extra of VA. From this, if you calculate VA, if you rearrange and if you calculate, you will get VA is equals to V1 by 3 plus V2 by 1.5 plus 667 I1. If you substitute, we need to substitute this third equation in 1 and 2 so that the VA component or the VA term will be eliminated. If you if you put this value VA in the I1 equation, what you will get? I1 is equals to 233.34 into 10 power minus 6 V1 plus 0.6 V2. You can easily calculate using calci. Then I2, if you want, then same way VA will substitute into equation 2 and find. And here one more thing is, you have in the VA 667 I1. Anyway, you got the value of I1, substitute that also. Then you will get I2 is equals to minus 48.89 into 10 power minus 6 V1 plus 39.9 into 10 power minus 3 V2. Now Y parameters are this, all are the Y parameters. This is Y11, this is Y12, this is Y21 and this is Y22. If you want, you can write the general equations for all the questions so that it will be easy for you to comparison Simon, so that the examiner also will be thinking that the person knows the concept. So if you write the for formula also, you'll get having marks. I think I didn't write the formula here. Please note down that you need to write the formula like I1 is equals to y11 v1 plus y12 v2. Then I2 is equals to what? y21 v1 plus y22 v2. If you compare these two equations with these two equations, you will get as y11, y12, y21 and y22. Write these two equations, the main general equations of y parameters for all the questions. Employ an appropriate method to obtain y for the network. We will see now this. If there is a dependent source, how to calculate. What it is, which dependent source this is? Current dependent current source. Why? Because depending on the current value, and the source is dependent current source. So if you see here, what we will do, we'll take two nodes v1 and v2 and the reference node as this. After that, what we will do, we'll write apply KCL to node 1. If you see apply KCL to node 1, here there is a little bit I need to explain is what. If you see, I1 is incoming current. Anyway, you have this as if the current is moving in this way, I1 is incoming current. I1 is incoming current. Outgoing current, what you have? Outgoing current, if you consider this is V1 minus, and one more voltage we can form, that is 5I1. 5I1 is also what? The voltage across this network. So what we need to do is, we need to write V1 minus I into R, that is 5I1 by total ohms is what? I1. I hope you understood. The current across this whole thing is what? Is I1 is equals to V1 minus 5I1 by 1, and one more it is what? The current which is outgoing, that is 0.3 I1 we are going to write. After that if you see, if you calculate this, you will get I1 is equals to V1 by 5.7 plus 0 V2. There is no V2 component, so it will be 0. Then apply KCL to node 2. If you apply KCL to node 2, if you see I2 is the incoming current, I2, and 0.3 is also incoming current. So 0.2, not 0.2, 0.3, that is equals to V2 by 2. If you see I2 is equals to V2 by 2 minus 0.3 0.3 into I1. I1 is what you got as V1 by 5.7. If you calculate, I2 will be what? Minus 1 by 19 V1 plus 0.5 V2. We already got I1 and I2 equations in terms of Y and V. Y11 will be 1 by 5.7 Simon, and Y12 will be 0 Simon, and Y21 will be minus 1 by 19 Simon, and Y22 will be 0.5 Simon. 0.5 Simon. These are the Y parameters. You got it. Okay. Then you can write in the matrix form. That is, if I forgot to write the Simon or the units, please do write. Anyway I'm writing in the video, but if I am not writing, just keep remembering that you need to write the general equations, that is I1 is equals to Y11 V1 plus Y12 V2 plus then I2 is equals to Y21 V1 plus Y22 V2. If you write, it will be like you know the concept. They think for solving the sum I didn't write. You write those equations initially. For if they want admittance parameters or Y parameters, first what we need to write, I1 is equals to Y11 V1 plus Y12 V2. I2 is equals to Y21 V1 plus Y22 V2. You write that first. Then you apply KCL and KVL. So that will be easy. So you got Y parameters. Now the sums are done. Theory is done. I hope you have got to know what are admittance parameters. That is Y parameters. It is also called Y parameters. Similar question I have given You can solve it. I have given even the answer. You can check with this. Then if you have any doubt, you can put it in the comment box. And obtain a complete set of Y parameter to describe two-port network. The same similar question I have done in the previous slides. You can compare that and you can do. An answer is also given. If you have any doubt, you can put in the comment box. And if you want any other concepts to be done, any sum to be solved, please do comment and ask me. I will do a video and upload. Now what we are done with in the module 2, first topic, that is two-port network, we are done with one-port network and admittance parameters. Now we are left with other 4 concepts that completes the module 1 first topic, that is two-port networks. With the new topic, I'll be sharing with you the new topic video in the next video. Thank you for now. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.